Hello everyone, welcome to my YouTube channel, and the question for today is coin chain. So basically we are given coins of different denomination and the total amount of money, that is amount, and we have to write a function that will compute that will take the fewest number of coins that will be needed to make up that amount. All right, and we have to return the number. Basically we have to return the number of the coins that would be used, or otherwise we have to return -1. All right, so suppose like if we have to make like 10 rupees and we have coins of 50 and as well as 100, so we cannot make this amount with the help of this coin, so we will return -1. So all right, so this is the case here over here. So if we are not able to make it, we have to return -1. So this is the thing that is given to us. Let's see for the constraint that are given. So let's see for the other constraint that are given to us. So the constraint given here are that the length of the coin will be up to 12. So the array in which the different coins will be there, it would be from 1 to 12. So it would contain at least one coin that we know of. So we won't be putting any base condition for this. And the value in the coins array can range for the max int value and up to max int value, and also 1. So that is the 2 to the power 31 minus 1, that is the integer dot max value we have, and it will have 1 as well. So if we have to make 0, we can't make 0. So for 0 it will be 0 only, and because 0 is nothing in denomination, so we won't making that as well. So it will start from 1 only. And also we have to make what amount that can be 0, so we have to put that in mind. If we have to make 0 only, then we will just return 0. So amount can be that, but coins cannot be that. So this is the case. So it's very important while attempting the question, first to look at the constraint, because these constraints also help us to get the basic idea about the base cases that we put in our code. So whenever in the coding or the competition point of view we say, so it's really important to look at these constraints. These will always help you to counter the corner cases that we have, like the very base conditions, where because we are able to make our whole code, but in some base conditions we are not able to satisfy them and our whole of our code fails. So it is very important to look at the constraint given to us. First understand the question and then look at the constraints that are given to us. All right, I hope the question is clear. We will solve some examples for it, and let's see how you're going to solve it. All right, so this question is a very standard problem of dynamic programming. So the approach we will use here will be the dynamic programming and the bottom up manner. What I mean by the bottom up manner is that we will look for some initial cases, so some initial values, and with the help of that value we will be able to make our final results. All right, so let's see with an example, it would be more clearer then, and let's see how we are going to implement it in a bottom up manner. All right, and take the help of the previous results and make our final result. All right, and one such benefit of using dynamic programming is that it would give the result in O of n complexity. All right, so this is a very great advantage, or log n or n log n complexities. It avoids n square complexities. So whenever possible we should use dynamic programming, and these question and the the hint or how we can get intuition for dynamic programming is that in where we have to make use of previous value. So suppose I have to make amount 11 and I have a coin 1 only. I have coin suppose of 2. So I'll just do nothing. I'll just subtract 2 from it, and what I get 9. So I will see that how many coins are required to make 9, and if I know how many coins are required to make 9, I'll just add 1 to them, number of ways 1 to them, because number of coins used to make 9 suppose should be x. So adding 1 to them would give me 11. So that's how we will going to use the previous results and compute our final answer. This approach going from this point to backward position is called top down manner, and coming from 0 to this value is called bottom up manner. These are the concepts of dynamic programming. I won't discuss them in detail in this question, but these should be clear as to why we use dynamic programming over here. All right, why we are storing the previous value and why we are using them again. All right, I hope it's clear, and let's see. So let's see with an example in this case. All right, so suppose we have the coins 1, 2, 4, 5, and we have to make the value, let's say 10. All right, so we have to make 10 with the help of these coins. All right, and I won't discuss the basic approaches for this because it will just waste the time. I'll simply jump to the DP1 approach. The various approaches can be like making every pair or brute force approach and things like that. We won't discuss them. All right, so let's see for the best approach for this question and how we will solve this with the dynamic programming. So what we'll do is, for this amount I will just take an array of 0 because I want to see how many moves will require to make previous results, and based on them I will compute my ways to get this value. All right, so I will declare one array and these are the indexes. So and I will either fill them with the maximum value I know, because that will be the maximum number of way, and it will be easy for me to compare if it's minimum. So I'll get just the minimum of both, either the value that is still inside or that. For 0 I will say it's 0 only, because as we all know, if 0 is there, so 0, this is our base case as well. All right, so let's see for this question how we'll make 10 from this. All right, so I have declared an array with 10 plus 1 value so that I can get the answer for 10, and I will return that only, amount plus 1 values, as we say for the code. And this is my coin array, and let's see for the 1. All right, so I am at here. Okay, I'm traversing this. So what I'll do is I'll just traverse this array and I'll see for the values, and let's see how it's done. So first is the 1. All right, so I compare 1 with the 1. So I can see that 1 is less than equal to 1. So 1 is less than equal to 1. So the number of ways would be the, okay, so let me fill with the maximum value. That could be 11 only. Amount plus 1 would be the maximum value here. So let's fill the array with the maximum value what we have here, and let's now run our algorithm. So what I'll see is I'll pick this coin up. So the number of ways to make 1 will be and 1. So 1 will be with this. I compare this. If it's less than that, so either I can use this coin. So I'll compare 1 with the 1. So I can make this. So I will either choose what's the value in here, that is 11, or I will choose the minimum of both, or either 1 or the value that is there. So it's the value that is there is 1. So I'll 11. So I'll update it with 1. Alright. So either I will pick the value that is there, that is 11, or what I'll do is I'll pick the minimum of both. So or either I'll pick 11 or the minimum of 1 minus the value I minus the coin j. So that will be 1 minus 1 and that value plus 1. So I will go back and I will see what are the minimum number of ways to, if I have like for here I told you like what if I have to make 10 and I have a coin of 2, so I will go one step back to 8 and I'll see what are the minimum steps to here, because I have already computed till then, plus 1 because I have used that to make this. All right, so I'll here also I'll do nothing. I'll go back and see one step back and it's 0 plus 1, so it's 1 only. So I'll update it with 1. All right, I'll compute this and update my this array in place. All right, so now it would be Oh, 1 over here. Alright, now for 2. So now for 2. Alright, let's see how our algorithm works. So it can be made from 1, from 1, 1, 2 coins. So it would be either, let me delete it when we are starting at here, because after that when we go from coin j, so we have it's less than it's greater than that, so we'll just don't loop it, and we'll go out again loop, and we will increment the value of I to 2. Now we'll make 2 and coins will be again be initialized to 0. So we will see from coin 0. So here 1 is less than 2 and it's 11 by default. So 11 obviously its maximum value, and our answer would be updated as we move on. So it would be we will take help of 1. So either it would be 11, either it would be the value that is there, that is 11, or dp of I minus the value coin j plus the value of coin j plus 1. So it would be dp of 1. Alright, so that is 2 minus 1, that would be alright. So 2 minus the coin j value is 1 plus 1. So to 1 make it's 1 only. So 1 plus 1 2, 11, or 2 minimum is 2. So we'll update it by 2. Alright, now we increment our value for j, that is for the coins array. So this is my j and this is my I. Alright, to make it more clear, so I then increment it. So now I have again 2. So now either I'll take the help of minimum of them. So either I'll the value here is 2 minimum, or 2 minus dp of I minus coin j. So dp of I minus coin j in this case will be plus 1. So dp of I minus j, that would be 0, this value. So 0 plus 1, that would be 1. So either I will take 2 or 1. So minimum number of coins, so now it would be 1. So it would be updated and it would be set to 1. And by logic we can see that if we have one 2 rupee coin, so why will we be using two 1 rupees coins to make a value 2? We will use only one coin that is of 2 value, and we will use it to make the amount 2. Alright, and this is how we will doing by code, and this is for the logic as well. I think it's clear. And likewise I am updating all values, and it would be a little bit fast. I won't explain for every now iteration, and I would be increasing I increasingly. So for 3, let's say, so either I'll choose I don't have a coin for 3, so I'll choose either for 1 plus 2 or like that. So I'll just go for 1, and I'll choose 1 3 rupees coin or 2 1. So I'll choose 2 coins, so I'll just update it to 2. So it would be updated to 2. First it would be set to 3, and then in the second iteration, then I'll be using j, then it would be updated to 2. Alright, I hope it's clear. And likewise I'll be updating or. So here I have filled till 5, and for 6 I will do nothing. For 6 for one value I'll just see for this minimum of this plus 1, or minimum of 2 units I'll go back. So it would be minimum of this plus 1, or it would be 4 units back. So 6 minus 4 is 2, minimum of this plus 1, or then 5 units back. So alright, like this I'll be computing. So I have my answers for this, and similarly for 7 I'll do, and for 8 and let's see for final computation. I'll see what we have, and it's kind of a hodgepodge. So for now, for the value for to be done is 10. So I'll do nothing. 10 minus 1 is 9. I'll check for the value that 9 has, and dp of 9 plus 1, dp of 10 minus 2 is 8 plus 1, dp of 10 minus 4 is 6 plus 1, and dp of 10 minus 5, that is 5 plus 1. So dp of 9 would be 2 plus 1 3. So 3, we have 3 for this. Similarly for 8, and similarly for 6, but here we have 2. So minimum will be 2. So 2 will be, we will be placing here, and 2 because we will using 2 coins of each of 5 denominations. All right, so this is how we will code it, and this is our final answer, and this value will be returning. So I hope it's clear to every one of you how we are going to solve this problem, and how dynamic programming is applied, and how we look for the previous value and set it. And if it's still not clear, let's see the code, and I hope it would be much more clearer then. So let's see the code for this. So here is the code. It's very short and precise, and I've taken one maximum, and that would be the max value that would be filling. And I have initialized my DP array, and I have filled my DP array with max value, and I have taken DP of 0 as 0. For 0 value it will be 0, and now it's my loop. Alright, for I have traversed my DP array from I equals to 1 to less than 2 equal to amount, because it's amount plus 1. Alright, this is my DP array. For every value I'll be checking if its value is in corresponding points is less, so I'll be doing nothing, I'll be computing that value, or the value which I get from subtraction of the I minus the coins that I explained in the video, and adding 1 to it, because I have to include that coin as well. That would be set in my final array. So after this whole process, at my amount variable will be set in the bottom of manner, because of the previous results I will get my final result in this case. And either if it's greater than amount, that is if it's maximum value, then I'll return -1 because it's not possible to make it, or else I'll just return what is the value at amount. So let's try to submit it and see. So yeah, it's accepted. So if you have any doubt regarding this question, you can ask me in the comment section. Please like this video, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye bye.